Welcome to this tutorial on Google Earth, and we're going to look at the Google Earth system for landscape archaeology. I'll give you a brief introduction to the system, and after that we'll look at how we can use this platform to do some basic GIS style interpretations for archaeology. So to begin, let's take a look at the interface, the program itself. Here we have a search bar up top, and you can search for any place in the landscape that is in the archive of Google Earth, and you will find it. For example, might as well just take a look at Halifax. And you can see that it's not just the place, well, the UK place, another option, even the airport, things named Halifax in Pennsylvania. So lots of options, and that's how that system works. So you can engage that and go for a little bit of a tour. This can sometimes help you find even small communities that you're not quite sure about. Beneath that, we have a places file directory, and this is largely customizable. This is where when you do your own work, you can save it in a folder system, and therefore you will have access to those points that you make. I'll show you in a moment how to do this, but this, for an example, is a list of points that I created indicating fur trade posts operated during the career of Nicolas Denis in the 17th century. So I can put these points on a map. Not all fur trade posts actually, but did some lumbering as well. So this is an example of how you can create some of your own mapping with this system, and all of those things that you create get organized in here into a folder system. You can even change as you'll see, you can change the icons and customize this system a little bit. The point here is that all of the things that you create will live in this area in a folder system, just like on your computer, your laptop, or your tablet. Beneath that, in this Layers tab, we have a variety of features that Google Earth has already built in. For example, let's just pop out a little bit and we can hit the borders and labels features. And so that feature class shows up, and now we can see state borders, provincial borders, and international borders as well in yellow between the United States and Canada, as well as a variety of place names. And if you experiment with these various things, you'll be able to see more. Oftentimes when we're doing archaeological prospection, we leave most of these blank because they don't generally contribute a great deal to what we're trying to do, which is really look at a historical environment. Now we've gone through this side of the screen, so searching, storing your information, places, layers, what Google is giving you. We also have a variety of other features here that you should take a peek at. The obligatory compass rose, which allows you to change the orientation of the map. Sometimes it makes sense to do this, as in the case of Nova Scotia. If you're trying to fit something on a page, that might be a more convenient orientation than that. I don't know, it's just an example, but that's sometimes helpful. We do have within this compass rose tool a series of little arrows, and what they allow you to do is change the angle of the camera. And so in effect, you're able to tilt the surface of the Earth as if you're in an airplane. And then you can look around a little bit. I think some of us have seen this view flying into Halifax. I'll point out that a couple of additional features here become interesting over here in the layers area. If we wanted to, we could turn on terrain, which, as you can see, starts to give a little bit of relief to the landscape. You'll notice that George's Island sticks up now. A little crude. It's not exactly LiDAR derived data, but it's perhaps better than nothing. And in some environments, particularly urban environments, you're able to turn on 3D buildings, which initially are looking pretty gross, but there we go. They've resolved themselves. So you're able to create a little bit of a more realistic view of the environment. Again, much of this will not necessarily interest us because we're primarily interested in the past. But you have to admit, this is an interesting set of features freely available. And I'll show you now how we can use this more for archaeology. We're going to remove the terrain, remove the 3D buildings, and restore to a vertical perspective. There we go. Okay, time travel. So we're going to take a look at how we can apply historical imagery to this environment. And I think what we'll do is we'll take a look at this area here. This is modern day Truro. And in this area, we know that in the early colonial period, there were a number of Acadian villages. And you can see why by just looking at the landscape, looking at the nature of the water, all of that suspended sediment, and of course, these quite lush and fertile tidal estuaries, so the rivers emptying into this arm of the Minas Basin. These rivers are fringed with tidal marshes, and they attracted farmers who employed dike building technology. So we know the Acadians were living in this landscape, and what we're going to do is we're going to take an old map and we're going to lay it over this landscape. We're going to drape it over this landscape in an effort to see where the villages correlate to the modern surface of the earth. So in order to do this, you go right up here to a little tool called Add Image Overlay. And when you do that, it's going to ask you to go into your own directory system. So here we go. You get a little dialog box, little window, some controls. We'll browse, and you'll go into your own system. I have a folder called Colonial Mapping, and in that folder I have a series of maps of different regions, and I like this one. This is from the British Library, so I'm going to use that map. Okay, there it is. Now once it appears, we can see right away that it's a very small scale map. It's a large area being depicted. So we're going to do our best to fit it in there. And full of controls for you. We have a little diamondy box that you can grab, click and grab, and it'll rotate around that central pivot point. You can also click and drag from that central pivot point and move the map around. Furthermore, you can grab any of these other green corners or edges, but when you do, I would encourage you to hold down the Shift key first, because by holding down the Shift key, you preserve aspect ratio and the map will change its size in proportion. That way you don't introduce distortions to the map, either by stretching it lengthwise or stretching it top to bottom. Once you stretch it that way, you can't hit an undo button. So it would be possibly best to hit cancel and just reintroduce a new map. Okay, another very important tool here is the opacity slider. And that allows us to sometimes see both areas at once. So in the historical map, I'm looking for this little part of the Minas Basin, the upper part of the basin leading in toward Truro. And as we can see, The modern map, it's right about here. So I'm now going to have to change the scale of this map in order to make this work. Looks like it's going to have to get larger. Easily. But we'll just give it a rough, very rough attempt. Now I see one thing that's a little bit problematic is that I'm nowhere near the right scale yet, and I'm looking for clues to help me to sort this out. So clue number one is we've got a large river here called the Shubenacadie River, and when we go out here we can see the Shubenacadie River is right here. So I've actually got a little ways to go in terms of stretching this map and making it larger. Here we begin to encounter some of the difficulties imposed by the accuracy of the original map. This may be almost as close as we can get it at the scale of the entire landscape. And you can see that the minus basin, as depicted in this map, does not exactly correspond to the minus basin in real life. And we've done almost the best we can, because any changes introduced to the map are proportional when you hold down the Shift key and you do this. It may be reasonable at this point, if you're trying to fit things in one dimension or the other, to break that rule I mentioned before about aspect ratio, and perhaps stretch it or bend it in one dimension only. Of course, in a GIS context, we would be looking for multiple fixed points, multiple control points, and the software would adjust the map in a much more sophisticated way to make it fit. This is a very crude rubber sheeting exercise. But nevertheless, it does provide an illustration. Okay. Good enough for now. So here's our 18th century landscape. And here is the modern landscape. And if you can achieve a good fit, you can, in this way, generate a model of where one might go looking for these archaeological sites. Indeed, once they're found, thanks to this map, we can even name some of the communities and even some of the families living there. So that's terrific. Let's assume that we're happy with that fit. In reality, we're not. We hit OK. Well, before we do, let's name it. This map actually dates to 1755 and comes from the British Library. So if I hit OK, it will fix itself into the landscape at that opacity. And you can see now that it's appeared right here in my places. If I ever want to go in and adjust it again, I simply right-click, Properties, and I'm right back to where we were before. I can make those adjustments. We can make that map layer visible or invisible to our preference. Now this exercise gives us an example of the perils of trying to make a very, very large area map accurately onto Google Earth. As we can see, we focused on this part of the landscape around Truro, and by doing so, we acknowledge that some of these areas over here are not going to fit very well. we're not focusing on those. And had we brought this in farther, it would have imposed distortions over here. Therefore, it's better when possible to work with smaller areas of the landscape. And I'll just give you one example of what I mean by that. And it's going to be a very small part of the landscape. We're in Windsor, Nova Scotia, and we're looking at Fort Edward National Historic Site. So it's a British fort built in 1750. And here too, we have plenty of early mapping. So let's go add image overlay. We'll go back to our file system of Fort Edward in 1757. Okay, here's the map. And once again, we have the usual controls. We have the ability to change opacity. We have the ability to rotate the map, slide the map, and resize the map. Now in this case, we have the benefit of a small area to work in. We've got 4 bastions, so it's a star-shaped fort, and they correspond to features on this map. Moreover, we've got a surviving building. This building right here is a blockhouse, part of the original fort. And if you look on the map, this thing called A in the legend is the blockhouse. So now we really have excellent ground control points, points that haven't moved. And so what we will now do is play our usual game, but this time with a little more confidence. And that's really handy because it allows us to now take a look at what some of these other buildings are. For example, in this bastion over here, we have what looks like H and G. Of course, the script is upside down now, but H is a bakehouse and G is a kitchen. This method equally works with air photos. So if you've got old air photos, say from the 1950s or 40s or even 30s, you can add them to the satellite inventory in Google Earth. Now the final thing I'd like to show you, assuming we had this fairly accurate, is that you can add points. You can also add lines and you can add polygons. And this goes back to this whole notion of places. You can create features. So points can be created with this icon here, add place mark. And you can move it around. And drop it in place if you like. You can change the icon, you can change its size, you can change its color. And you can give it a name. And the important thing here is you can see that its placement on the map correlates to the easting and northing of the underlying grid system. So down here at the very bottom, we can see the easting and the northing UTM coordinates moving. That's critical because then you can use the same coordinate system with your GPS or, for that matter, with your phone to navigate to this point in the field. So you can create points, you can create paths or lines. You wanted to trace features that you'd like to, for example, walk in the field as part of a survey. You can create those lines in that fashion. you can also create polygons. Let's just say we had a really good fit with this map and we wanted to go in and create a series of features. Once we had those features mapped, we could then draw them in the landscape and create a series of maps. For example, you can see that my fit is not ideal because I'm already extending into the Bastion with this. Once again, you can change the properties. You can go into style and color. You can change the line color. Maybe I want a black line, perhaps a pale fill. In fact, you can even go in there and change the opacity of the fill. Here we have 60% opacity. Just gives a slightly different effect. And so in a landscape, when you're doing this kind of work, you can very easily use your overlay map to create a model of the surface and then add to the model by emphasizing certain features, drawing your own polygons. And you're left with a map of a variety of interesting features in the landscape at whatever scale. You can even use this tool to conduct some fairly basic analyses and measurements. We have the ruler, which you can set the units to, and you can measure distances. Wow, that would be 16.25 meters. Well, what's the distance from bastion to bastion across this fort? Approximately 85, 86, 87 meters. That's great. You can measure a path. Supposing you did want to walk around this structure. We go way around there. Over 400 meters to walk around. Or a polygon for that matter. You might ask, what's the area of this fort? Approximately 362 meters squared, or 0.81 hectares, and you can also change it to, for example, acres. 2 acres. These are useful calculations when looking at agricultural landscapes and correlating areas in the environment with, for example, maps of farm fields and census records. Remember, behind all of this, we have UTM coordinates down here at the bottom. And if we are careful, we use our terrain, we can even see elevation just below the word Google here. You can see differential elevation as you're moving around the site, moving your cursor. So here we see we're coming upslope. No surprise, the fort occupies the highest land, and then down it goes again. Lots of interesting features here in Google Earth. And to export the map, just say you've done your work and you've made all of the features that you want. You simply go to File, Save, Save Image. And it gives you the option of having a title, you can adjust the size of the image. It can be the current size by default, or it can be a very large one. It tends to shrink your text if it does that, but it becomes a more high-res map. You can edit your legend, include different features there. I quite like having the scale and the north arrow. So map options, you can add or remove these features. See that they're all gone now. But I would suggest at a bare minimum, you should always include the scale and always include the compass. You can see them down here. Once you've finished that, you just hit Save Image, and you can save it anywhere you want in your directory system. From there, you can import it into a report, a poster, a presentation, and you're on your way to doing some time travel and archaeological analysis with Google Earth.